this lesson on measurements, we are going to focus on volume of cylinders, cones, and spheres. So an overview of this video is, first we're going to look at the definitions, then briefly on the formulas for the volumes, and then finally looking at some practical examples. Now, the definition of the cylinder is a cylinder has two circular bases and a uniform lateral surface connecting the circumferences of the bases. Now, it is not necessary that you know the definitions of by heart, although you need to be able to identify the cylinder, cone, or sphere. Then for the cone, a cone has one circular base and a lateral surface that narrows down from the circular base to a point. And then finally a sphere, which is basically a ball, is a solid round figure or surface with every point on its surface equidistant from its center. Alright, so now that we know what we're working with, let's look at the formulas. First of all, for a cylinder works exactly the same as a prism. We take the area of the base and we multiply it by the height. And if we are working in terms of radius, since we are working with a circle and then h for height, our volume of our cylinder is pi r squared times by the height. And then for a cone, now a cone works exactly like a pyramid, and what we did with the pyramid, we take the area of the base times by the height and we multiply that with a third. So in this case, a cone has a circle as a base, meaning we are working in terms of a radius, so we have a third times by pi r squared times by the height. And then a sphere, this one you just need to learn off by heart. This is the volume, it is 4 over 3 pi r to the power 3. Okay, so now let's look at the examples. So for example 1, it says a Pringles container has a diameter of 7 centimeters and a height of 23 centimeters. Calculate the volume of the container. Alright, so first of all, what we're going to do is we see that this is a cylinder, and therefore we write down the formula of the cylinder. So the volume is the area of the base, pi r squared, times by the height. And another thing we have to be careful for, here they give us the diameter, meaning if the diameter is 7, our radius will be 3,5, half of the diameter. And now we basically just substitute in our values. So our radius is 3,5 squared times by the height, which is 23. And then we type it into the calculator. And that gives us, if we should write it in simplest third form, this is what we write down. If we should write it to decimal places, let's just round it off to 2 decimal places. If they don't tell you, you normally round off to 2 decimal places. So 885,14. Okay, and this is centimeters, and since we're working with volume, it's centimeters cubed. Okay, next up we have a party hat shaped as a perfect cone, and it has a height of 22,86 centimeters and a radius of 7,62 centimeters. What is the hat's volume? Now, since it is a cone, volume is a third of the area of the base, which is pi r squared times by the height, and then we just substitute in our known values. So pi times by my radius is 7,62 squared times by the height, which is 22,86, and then we type that in. Okay, so this, if we should round this off, it will round off to 1390. 1390, and that is centimeters cubed. Right, now Pixar Animation's ball is a sphere. If we estimate the diameter of the ball to be 50 centimeters, what is the volume of the ball? So if the diameter is 50 centimeters, that makes the radius equal to 25 centimeters. And our volume for a sphere is 4 over 3 pi r to the power 3. We simply substitute in the value and we calculate it. So this is going to be 25 cubed, and then we type that in. And then to 2 decimal places, we've got 65,449,85. 5,449,85. All right, and that is once again in centimeters cubed. Okay, now the volume of a hemisphere is this, and then it says calculate the radius. So we know that a sphere's volume is basically 4 over 3 pi r to the power 3. Now, since this is a hemisphere, the volume is going to be half that of a full sphere. So we're going to say half of that, to multiply it by half, and then we just substitute in the value. So the volume will be 8192 pi over 3, and then that's equal to a half times 4 over 3 pi, and then r is the one we want to solve for, so that's r cubed. Now there are many ways to solve this. We can actually just take all of this going on here and divide it by that, or we can maybe simplify things first here, and then maybe do cross multiplication. So I think let's simplify a few things. Let's say we've got 192 pi over 3 equals to, so this is just 4 pi over 6. Let's just write it like that. Now I'm not going to waste a lot of time to simplify it any further. I just think it creates more work. So what we can do here, since we have one term equals to one term, we can just use cross multiplication as well. Now once again, you can just say this fraction divided by that fraction, but I'm just going to use cross multiplication. So that means we have 8192 pi times by 6 over 3 times by 4 pi. Okay, now what I'm going to do here is I'm going to cancel out the pi's. We could have cancelled it out here as well. So I'm just going to cancel out the pi's here. Equals r cubed. And then we can take the cube root of that. So r is equal to the cube root of 8192 times 6 over 3 times 4, which is 12. And then we type it into the calculator exactly like that. So you're going to say shift the cube root, and we're going to have 8192 times by 6 over 3 times 4, or just 12, and that's 16. And our units, they haven't given us units, so you can just say units. Alright, now for the final example, a cylinder with radius 4 units and height equal to 25 units has the same volume as a cone with radius of 7 units. Calculate the height of the cone. Okay, so here we have two options. We can either we can either set up one equation where we have the volume of this equal to the volume of this, because both of the volumes are equal, and then we'll just have one unknown where we solve for h. Or we can do it separately in separate steps, where we're going to first calculate the volume for this and then use it to solve for h in a separate equation. So let's actually do it step by step. Let's start with the volume of the cylinder, which is equal to pi r squared times height. We substitute in our values. Pi, the radius is 4 squared times by the height is 25. And then we calculate that. So shift pi times 4 squared times 25. And that gives us 400 pi. Now I'm not going to round off anything at this point because that's going to affect the accuracy of our final answer. I'm just going to write it in simplest form. And then next up we have the volume of a cone. This is a cylinder. And then a cone. And that is equal to a third times by pi r squared times height. Okay. Now we can substitute in the volume. We know the volume, which is equal to the volume of the cylinder. And we can substitute in the radius and then just solve for the height. So this is 400 pi is equal to a third times by pi times by the radius is 7. So that's 7 squared times by height. Now in this case I'm just going to take all of this because it's times with height and divided both sides. So this gives me height is equal to 400 pi all over a third times by pi times by 7 squared. Okay. Once again I'm just going to cancel the 2 pi's and then I'm going to type in everything that's left into the calculator. So this gives us 400 over a third times by 7 squared. Okay, so rounded off, that gives us 24,49. And once again, this is just units right there. Okay, then we are done.